Thank you, Heinz. Have we got my speaker on here? There we go. Well, I should introduce my wife first. She's here with me this evening. Jeanette, would you at least wave your arm? She does. She's in bachelor. She's beginning to get like the Dr. Dwayne Gish's wife. I don't know if you remember Dr. Gish. He and Dr. Henry Morris were the founders of the Institute for Creation Research, but she gets to travel with me when I speak a lot, and Lolly Gish, who was Dr. Gish's wife, actually wrote a book called Traveling with a Creationist All Over Creation. And she's gotten to do that as well. I also should introduce my pastor from Darrington, Mountain View Baptist. Pastor, he and his wife are here, and some people from our church. So they're encouraging me. The topic I'm going to be talking about this evening is one that I tend to try to shy away from most of the time because I've had so many questions about the topic. It could have taken me away from the ministry I had in dealing with creation and the origins and the age of the earth and that sort of thing. But wherever I go, people always ask this question in the question and answer session, so I have to address it to some degree. So we're going to do that tonight because it's an interesting topic. It is one that's very controversial. I'm sure in this group there's probably opinions in all different directions. What I'm going to do tonight is give you my honest opinion about global warming. And basically the bottom line, there is global warming going on, but it's probably mostly natural. Whatever mankind has produced, it's a relatively small contribution. But it's being blown out of proportion completely by the situation we live in this country. It's being taken advantage of, and I want to explain how and why it's being done in that way. So we're going to talk about this topic in some detail. To start off with, we don't know whether to call it global warming or climate change or some other topic. It seems like the title keeps getting changed around. It was politically correct to call it global warming for a number of years. Then, because that became a bit of a hot topic, the politically correct terminology was climate change. Now they're trying to look at maybe we should go back to global warming again. So it's even controversial on what you call it. One of the reasons it's so controversial is we have a lot of climate alarmists out there. And they're claiming that all the glaciers are going to melt, the sea levels are going to rise, coastal cities are going to be flooded, Los Angeles, New York, Miami, and maybe even Seattle are going to be underwater in another 75 or 100 years. The Arctic will be ice-free by 2014. Wait a minute, that was 2 years ago. Well, all the polar bears are going to drown. Only a few more years to save the planet. Even Steve Hawking, just this week, came out with a statement, we need to leave this planet because we're destroying it. Within 1,000 years, it's going to be unlivable. We've got to find another place to move to. So it gets completely blown out of proportion, as you can imagine. We're going to try to talk about some of these topics in more detail. Now, I found over the years that there are a number of basic motivations or underlying issues that have kind of led to this this problem. And the first two on this list I discovered many years ago and have talked about this, but recently I found that there's a couple more. The first one, globalism, is what kind of drives this whole thing in many people's minds. There is a movement to do away with nations or do away with nationalism. And it turns out the atmosphere is a great tool for this because the atmosphere is bounded only at the bottom surface and maybe somewhat at the top, but horizontally the atmosphere circulates around the earth and cannot be bound by political barriers. For example, the air that we have right over us tonight, there's a river of air called the jet stream that goes all the way around the earth, and it does this on the order of about a week to 10 days. The air that's up above you right now will go around the earth and be back over us in about 10 days. That becomes a problem when you've got things like fallout from nuclear processes and so on. like the reactor that blew up in Russia a number of years ago. Within a matter of 10 days, there was radioactive material from that nuclear reactor in Russia falling out over the western United States and here in Washington. A lot of concern about that. So it's a natural way when you want to have, if you have a global agenda where you're trying to make a political change, to use the processes of the atmosphere to expand that agenda. That's one major effort. Another one is that the scientists who are involved in this whole issue of the atmosphere, and particularly global warming, they tend to find that it's easier if you refer to global warming to get funding. In fact, if you say that the sky is falling, you can get funding from the National Science Foundation or the Department of Energy to fund your research. In fact, it's gotten so bad in the last few years that if you don't at least include some reference to global warming, you're likely not to get funded for anything you want to do, whether it's looking at frogs or looking at snow or looking at anything. Somehow it has to have some kind of an impact on global warming. So a tremendous amount of research funding is given just because it has something to do with global warming, whether it exists or not. Well, there's another issue that I discovered a few years ago that drives this, and that is that in 1970, when I went to graduate school at Colorado State University, we had just come out of a period of about 30 years of cooling, atmospheric cooling or climate cooling. In fact, it had, from 1940, which was during the Second World War, and before the age of industrialization really got a hold in this country, before we were putting out much carbon dioxide at all, the climate was cooling. In fact, it was cooling so much that people were afraid that we were going to go into another ice age. One of my professors, Dr. William Gray, who is well known for, he's now dead, he died about 2 years ago, but he was well known for predicting the hurricanes for the next year, how many hurricanes we were going to have. And he actually took this on as a concern to the point of proposing to the National Science Foundation that we needed to take carbon black, that's the material that comes off of burning candles or kerosene lanterns, and load it up in airplanes like Air Force C-141s and dump it over the North Pole and the South Pole to allow the sun to heat up the poles and warm the planet back up again. Today, we're concerned the other way because it's begun to warm back up, and so we're now worried that we're going to go and become a desert or it's going to get too hot. So there was actually a period of time within remembered history in which we were worried about an ice age. Now this comes back into the way in which we look at planet history or what's going on in the past. The ice age that I refer to occasionally, which is another specialty that I've spent a lot of my research time on, is conventionally believed to have happened 20,000 years ago for the most recent one, and over the last several million years there have been some 60 ice ages. And when you look at it in that kind of a time frame instead of a relatively short time frame, which I believe actually happened and would be consistent with Scripture and the Genesis flood, it compresses this, it expands this time into a period in which there's a lot of oscillations before you get into another ice age. And so the concern is, if you put pollution into the atmosphere, whether it's gas pollution or particulates, it's somehow going to cause the atmosphere to become unstable and oscillate and then eventually go into an ice age. So there's the fear of a new ice age, and that drives a lot of the scientific community to try to avoid any potential perturbation of our atmosphere which would cause it to go into another ice age. Well, then finally, there's what I discovered just within the last few months. There is also something called the human or the anti-human movement. This is a movement which is actually taking away God's intention for man. We're a very special people that God created. Earth is our home, and there's no place like it in the universe. And God created us as special beings, but the general attitude today is, if we're just a product of evolution, we're no different than a monkey or a frog or some other evolutionary type animal. So there is a turn away from saying that mankind is special in any way. I first discovered this actually on a backpacking trip down in the Grand Canyon. And I discovered that about 20% of park rangers actually would like to see no people in the national parks. They say if it weren't for mankind being in the parks, this would be a perfect world. So we need to keep people out and save the parks for the future. Well, I thought that was a little interesting, a little strange, but I found that in fact it is true that that attitude is developed more and more. And in fact, it's developed to the point that that animals have same rights or even superior rights to human beings. In fact, there's the attitude we need to get mankind out and let nature return to the way it was before mankind was here. That's even extended to the point to give rights to plants now. There are groups that are saying farmers shouldn't be allowed to farm because it's harming plants. I mean, it's just gotten completely out of hand. So it's what I call the anti-human movement. There is 3 people that were really instrumental in the development of the global warming concern. And these were legitimate scientists, or the 2 of them were anyway. Dr. Roger Revelle, who I have great respect for, he was the founder and chancellor of the University of California at San Diego. And he was a well-known world-class scientist who was concerned about climate change and places like in Africa where there was desertification and drying of the climate, movement of desert into other areas and so on. But back in the 50s, he began to recognize that we needed to monitor carbon dioxide in the atmosphere, that potentially there was the possibility that carbon dioxide concentrations were changing. So he recruited a gentleman by the name of Charles Keeling, who you see on the lower left there, and they began a laboratory in Hawaii, on the big island of Hawaii near Mauna Loa. And a National Oceanographic and Atmospheric Administration began measuring the concentration of carbon dioxide. Now, I'll talk about Al Gore in a moment. I just wanted to show you what he looks like, if you've forgotten. This is when he wasn't quite so heavy. He's gained a little weight since then, if you've seen pictures of him lately. At any rate, at the Mauna Loa Observatory, I went over there a number of years ago when I decided, you know, there's all kinds of concerns about global warming. Is it possible that there really is some global warming going on? So I decided I needed to look at the data, and I went to Mauna Loa to see the laboratory where the observations were being taken. That's Mauna Kea. There's 2 big volcanoes on the big island of Hawaii, Mauna Loa and Mauna Kea. Mauna Kea is where the big telescopes are on top of the mountain. By the way, it snows in Hawaii. Did you know that? It snows on that mountain there. And Mauna Kea, where the NOAA has its laboratories for measuring various types of gases and other information. Now, that particular site was selected by Dr. Roger Revelle, and Charles Keeling then went there to take up residence to start the laboratory. And the reason they picked that location was it's out in the middle of the Pacific Ocean, about as far away as you can get from any continents where there were artificial sources of carbon dioxide from industry and cars and people. And so it would be a nice, pristine location to get a measure of the average concentration of carbon dioxide in the atmosphere uninfluenced by local sources of carbon dioxide emission. Now, it turns out there is, in fact, still a local source there. Occasionally, the volcanoes belch out a little bit of carbon dioxide. So you have to be concerned about the wind direction from the sampling location and then take out that data to get an average condition. Well, they did that, and here's what the plot looks like. The lower the scale horizontally is from 1958, when the laboratory was started, up to 2016, which is today, when I started to prepare this talk. I give this talk about every 4 or 5 years, so every time I do, I have to update it. But on the left scale is the concentration of carbon dioxide in parts per million. Now, it started in 1958 at below 320 parts per million, which is a very small amount. That's like 1/100th of, or 1,000th of 1%. It's a very small amount of the atmosphere. But it today has risen uniformly up to over 400 parts per million. In fact, it passed on the average over 400 parts per million this year. So that seems to be a major issue with the climate community. Now, in addition to going up uniformly, you'll notice little glitches up and down. Those happen to be annual oscillations. In the wintertime, well, let's start with the summer. In the spring and summer, when plants on the continents and plants in the ocean, phytoplankton as it's known in the ocean, as it's growing, as the temperatures warm up in the spring and summer, they absorb carbon dioxide. Plants absorb carbon dioxide to grow, and they release oxygen. So in the spring and summer, as they absorb the carbon dioxide out of the atmosphere, the average concentration goes down a little bit. Then in the fall and winter, when the plants die off on the continents and in the ocean, they release carbon dioxide back into the atmosphere, and it goes up. Well, Dr. Revelle was teaching at Harvard University at the time, and one of the students he had in class was Al Gore. And he made a statement that affected Al Gore's thinking amazingly. Dr. Revelle said, you know, it's almost as if the earth is breathing. And Al Gore, he began to develop a kind of a pantheistic view toward the earth. It's actually alive, it's breathing. You've probably sensed that when you've heard him talk from time to time. Well, now this information, this data that's collected is valid, accurate information. The carbon dioxide concentration in the Earth's atmosphere has been increasing. Now, I need to say that that is legitimate. You really shouldn't question that, because it's a good, solid piece of information. But what you need to realize also is that in Earth's history in the past, concentration of carbon dioxide has been much greater in the past than it is today. In fact, back during what I think was at the time of the Genesis flood, which is a period of time which conventionally they believe dinosaurs roamed the earth. You remember all those pictures you see with the dinosaurs, all the trees and plants and everything? Those trees and plants were growing because there was such a high concentration of carbon dioxide. It was 25 times greater than it is today, not 1/100th of 1% greater than the average today. It was much, much greater in the past. So there are periods of time in Earth history when it was much, much greater. Well, in addition to that observation, I decided to look at some other data which I obtained from the National Oceanographic and Atmospheric Administration online. And the data, which when I did this about 10 years ago, you could trust that data pretty well, because nobody had been dinking around with the data. In the last few years, however, there are people who've gone in and changed some of that data to adjust it to be more consistent with some of the ideas that they've had about global warming. So you have to be a little more careful about the data when you look at it. One of the pieces of data was from buoys that are stationed all around the Earth now in the ocean. They were put in starting about 30 years or 40 years ago, and these buoys will collect temperature and wind data, precipitation, solar insulation, and sea surface and depth, temperature of the ocean down at depth. So I looked at the sea surface temperature data and plotted that to see whether in fact there was an increase or a decrease in temperature from that data. I selected a buoy out in the Gulf of Alaska. Some of you who have been to Alaska, you know where this is at. It's down south of Anchorage, out in the Pacific Ocean there. I selected it because it was one of the oldest stations. At that time, it was about 35 years old, so it had a fairly long period of record. And I processed this on my personal computer, which about brought my computer to its knees, because they had collected data, sea surface temperature data, every second for 35 years. That's a lot of data. Well, my computer did crunch through it after a while, and I was able to plot it, and this is what I found. This is actually a later, this is not the data I did, but this is data similar to what I found. They're starting about I can't quite see it from here. Should be about 1960 there on the left. A little bit too small for my old eyes. Anyway, you can see that the temperature has increased slightly. Now it's all up and down and wiggly and all kinds of things. And here toward the end, and back about 2010 or so on, you see that it's actually begun to go down. There's actually evidence from this record and the atmosphere that the temperature has leveled off, and if anything, is starting to go down a little bit. So my prediction for the future is it's going to get cooler. At any rate, in general, the temperature has increased. Well, if the ocean is increased, not just in Alaska area, but in the tropics, you're likely to get more hurricanes, more intense hurricanes, and bigger hurricanes. And so I went back and looked at the record. Again, you can get this information online. Here is data from back, okay, I can see it over here. Back in the 1800s to about 2001. Now, we didn't have satellites back in 1851, so this information was taken by observation from ships and shoreline observations. But from about 1970 on, this was done from satellites. And these are tropical storms and hurricanes, and you can see that there is a trend upward slightly. Now, you'll find all kinds of statements about, no, hurricanes are not increasing, they're not getting more intense. It's because there's so much variation that it's hard to know for sure. But that's my assessment there. There has been a slight increase in hurricanes, particularly over the last few years before the turn of the century. And then there suddenly was a drop-off right around 2000. It decreased dramatically. Okay, one other thing I looked at, well, they were concerned that all the polar caps and the ice sheets and the glaciers are all going to melt. There is evidence for that as well. I looked, NOAA does a complete coverage of ice coverage around the North Pole every year so that they know what the ice coverage is. Not only its coverage horizontally, but the thickness of it. There, generally, you can see the purple line was what the average coverage was in the year 2001. The white is what it was in 2006, 5 years later. So you can see that's the minimum coverage in the summertime. Now in the winter it all freezes back up again and covers over. But each year it has been declining. Now if you look at it over a period of time for the last 30 years, you can see that there actually is a decline. Now this is 1978. It starts at a certain amount of coverage in millions of square kilometers, but it doesn't go to zero. It just goes from 16 million square kilometers to 14 million. It doesn't go to zero. But I think it's probably been much less historically in the past. You know the history of the Northwest Passage? All the explorers came out here, including Lewis and Clark, looking for the Northwest Passage. They thought Deception Pass was it. That's why it's called Deception Pass. They thought the Northwest Passage was draining out through Puget Sound through Deception Pass. Well, that wasn't it. You know where the Northwest Passage is? It's probably in the Arctic Ocean, because when it melts back, that today, because it's melted back enough, Japan and China are sending ships through the Arctic Ocean to take a shortcut to the East Coast. So it's not uncommon for the ice to change. Okay, now here's probably one of the most controversial, and this is the atmospheric temperature. This is measurements from literally thousands of surface stations all over the northern hemisphere. And this is a little bit of a complicated graph, so I have to explain it a little bit. It goes from 1880 to 2016. And by the way, these are direct measurements with thermometers. Anything before 1880, we didn't have temperature measurements with thermometers. We have to guess at what the temperature was based on what are called proxy information. For example, you can look at various geologic features that change as a function of temperature. If you can figure out how that changed, then you can estimate what the temperature was in the past. Well, this is direct information. And from about and by the way, the vertical scale here is a temperature anomaly in degrees centigrade. There is an average that you measure from 1901 to 2000. That'd be from about here to about there. And then you take the difference between that. The average is at zero. If you look before this time, the temperature was cooler. After that time, it's warmer. Now, during this period in here is when we think that from 1940 to 1970, this indicates that it was slight cooling, and then it started warming again. But see what happened here about 1995? It leveled off. And if this is related to solar activity, which I'm going to talk about in a moment, the indication is it's probably going to continue to decline. So this is what the whole controversy is all about. Is this temperature trend related to the increase in carbon dioxide today? Now, I need to say before I get any further in the actual data, we have to be careful because the data itself is suspect, and there's no way to simply separate this out. It turns out that the places where temperature is measured at weather stations has been affected by the growth of cities. Here is a station in Marysville, California. That originally, when the temperature gauge was located there and the data was collected, was out in some farmer's field. It's now surrounded by buildings and heating ducts, asphalt on the parking lot, which absorbs heat from the sun, and the measurements is in the little, I'm sorry, here's the shelter right here. The measurements are measured in that shelter, which are warmed in the daytime and at night don't cool off as much. It's called a heat island effect. And that's true on almost all measurement stations all over the world. As cities have grown up around these weather stations, there's a natural built-in warming trend into the data itself. And it's almost impossible to separate that out. So you would actually, from the data with nothing else going on, think that the temperature is going to be increasing simply by the data, the way in which it's collected. Okay, now there also are people who are invested in global warming. And there's a gentleman a fellow by the name of Michael Mann, who developed something called the hockey stick graph. He went back and took the data and applied his global warming model to the data and adjusted the data so that it actually appears to be flat, just slightly below zero here, from about 1000 BC. Remember, these are not direct measurements, those are estimated temperatures. He filtered the data so it appeared to be flat, and then suddenly starting about 1850 climbed dramatically in this period here. This became the hockey stick graph. Michael Mann is a scientist in England, East Anglia in England, which is a climate center, and he came under all kinds of scrutiny, and finally people no longer believe anything he had to say. And yet that is the basis for a lot of international organizations on saying that global warming is going on, that we've got to do something because the world is out of control, the temperature is climbing dramatically. Well, this was the standard temperature graph that I grew up on in graduate school back in the 70s. And that says that there was much more happened before. The graph from in 1800s and so on shows a gradual increase in temperature as well, where this is a different scale here, but it was colder and it was inclining up toward about 2000. It was getting warmer. But if you go back even further, you find that it was much warmer in the past. Around 1100 or 1000 AD, it was much warmer in that period in there. And then it got cold. Something called the Little Ice Age occurred in here, and then it began warming back up again. Now, this is quite interesting because this Little Ice Age, I believe, is related to solar activity. So it's much more complicated what has happened in the past. There was warm periods. In England, for example, during this warm period, they built the cathedrals. There was a lot of wheat growing. The grapes were being harvested all over England. Greenland was developed by the Vikings. They lived there and had farms there. And then the Ice Age came along. All the grape crops in England failed. Wheat was not grown as effectively. And Greenland, the Norwegians, a lot of you may have some Norwegian or Swedish background, the Vikings were run out of Greenland because it became a small ice age and became iced over. So there's a lot of history that goes on in terms of global change, and that all occurred naturally. I'm going to skip this one. This gets a little complicated to talk about. I'm getting too wordy anyway. Now, there's a major piece of information in this graph that helps you see that the change in temperature that I talked about, which is this blue line here, starting from about 1880 to 2000, this blue line is the temperature in the Arctic, and it increased for a while, and then to about 1940, then decreased to 1970, and then started warming back up again. Well, if the carbon dioxide continuous increase was the cause of global warming, you would expect that blue line to just keep on going up consistently, not do this sort of a thing. But when you overlay solar activity, which I'll talk about in a moment, well, let me go ahead and do it now. Solar activity is when the sun is active. It has more sunspots. It has more solar flares. It has a larger electromagnetic field that extends out from the sun. All kinds of activity going on in the sun, it tends to put out more heat, and it's warmer. Well, if that's related, you notice this particular solar activity, a measure of solar activity which involves sunspots, it follows that trend almost exactly. So you begin to suspect there's something else going on besides carbon dioxide. Carbon dioxide may have an effect, but not to the degree that apparently solar activity does. Okay, now there's two people that I see as current heroes in this whole controversy. One is Roy Spencer on your right and John Christie on your left. They're both associated with the University of Alabama in Huntsville. Dr. Christie is a specialist in satellite data. He looks at the estimate of the Earth's temperature from satellites in the upper atmosphere. Roy Spencer looks at surface temperatures from gauges like we measure on the ground, and they both come to the same conclusion that carbon dioxide is inconsistent with the measurements that they've got. And these two men are specialists, and they are skeptics of global warming. I'm a skeptic of global warming. I think it occurs, but not to the degree that is typically talked about in our scientific circles and our society as a whole. These two gentlemen talk about this, and they have the knowledge and the expert, and they're doing current research on it. And my position is almost identical to these two men, and I developed mine independently of theirs. There's also a number of other associates that I've had that have been well-known scientists. One was the head of the Academy of Sciences, Fred Singer, who is a skeptic of global warming. I'll go on from there, but there's a whole bunch of people. Here is one of the graphs that Dr. Roy Spencer has given to give you a broader perspective on global warming as well. This particular graph goes all the way back to the time of Christ up through the year 2000. You'll see our period in here, which is relatively warm with the little ice age in between. That medieval warm period that we talked about earlier, where the British and the Norwegians and everybody was flourishing. Then there was a cooler period before that. You go back to the Roman warm period. So you begin to sense that there is a variation with about a 1,000-year cycle. You've heard of the El Nino effect that occurs about every 7 to 10 years here off the West Coast or in the South Pacific. That has a period of about 10 years. There appears to be about a 100-year cycle, and here you're beginning to sense a 1,000-year cycle. This has been ignored by the global warming community. Now, Dr. Spencer has several other suggestions what may be behind this, and I have to say right now, we really don't know what is causing variations in temperature. We suspect some things, but many of these are different than just carbon dioxide. Roy Spencer's basic explanation, he thinks is probably the explanation, is the cycling of ocean water from the deep ocean. The oceans have gyres in them that the water in the Pacific, for example, starts in Alaska, comes down the West Coast, gets to near the equator and goes west across the equator and then up the east coast of Asia across to Alaska and then back down again. Same thing in the Atlantic Ocean. We have the Gulf Stream that goes up from the Gulf of Mexico up the east coast, across, bumps into England. And I don't know, you may not know this, but there are palm trees that grow in southeastern England because of the Gulf Stream crosses the Atlantic Ocean and runs into England, goes on further south, hits the equator, comes across back to America. So there's a big clockwise gyre in both the Pacific Ocean and the Atlantic Ocean. Well, in addition to horizontal gyres, there's also water coming up from deep in the ocean causing upwelling. And that has fluctuations in it. The El Nino that we talk about here in the Pacific is influenced by that, because during a period of the El Nino, water is brought from deep in the ocean up to the surface. When that happens, it brings up cold water, cools the atmosphere, and the ocean has much more mass to it, contains much more heat, and can absorb and release much more heat than the atmosphere does. So it's not the atmosphere that drives the climate, it's really the oceans. So Dr. Spencer believes that the fluctuations in the ocean is actually what's driving these cycles in the atmosphere. Well, there's other explanations, and I think this one here has probably got the best chance because of the relation we've seen between solar activity and temperature. The sun has spots on it. And I'm not going to get into the explanation of those other than the fact that it's like a pot boiling, and when the circulation in the sun comes to the surface, it cools that part of the sun more than it normally would, and it appears as black spots on the surface of the sun because it's cooler and it doesn't put out as much light. Well, in addition, we've got information all the way back to this is only a period back to 1900. This is the variation in the number, whoops, wrong one. This is the number of daily sunspots on the sun as a function of time from 1900 to 2000. You see it varies, and it varies with about an 11-year cycle. You've heard about an 11-year cycle on the sun. The number of sunspots is a minimum, goes to a maximum. This is on the order of 250 or so, up to about 500 sunspots at a time on the sun. And it fluctuates over a period of about 11 years. Well, we can go back even further, and it turns out sunspots, it doesn't take any real exotic equipment to see and count the number of sunspots. They were able to do that all the way back to the 1600s. And here you can see it back to 1600s. This fluctuations that we saw earlier for the last 100 years, you go all the way back, and it does that all the way back to about 1700, and suddenly there's hardly any sunspots at all. In fact, between about 1640 and about 1720 or so, there was almost no sunspots at all. It's called the Maunder minimum, the few sunspots. Now, guess what happened during that period of time? The Little Ice Age. The Little Ice Age. So we have the inference that the lack of activity on the sun may well be what's causing cooling and produces ice ages. So that we have to take into account. Now, here's a model that was developed by a Danish astronomer in which there's current research going on now, and it's exciting. It's being done in the CERN laboratory in France to try to see if this model is legitimate. It's a theory. And basically it says when the sun is inactive, that is, when there's very few sunspots, the electromagnetic field around the sun is contracted and the Earth is exposed out in space to cosmic radiation. When the electromagnetic field of the sun the electromagnetic field of the sun can actually divert cosmic radiation so it can't come into the Earth. But when it's not doing that, the cosmic radiation can come into the atmosphere and produce small particulates that can become cloud droplets and become more clouds. It's like a cloud chamber that's used in physics. at any rate, when you have more clouds, you have a cooler Earth because the solar radiation is reflected away from the surface of the Earth by all these clouds. On the other hand, if the sun is active, where there's lots of activity, sunspots and solar flares, the electromagnetic radiation from the sun can extend out beyond the radius of the Earth around the sun and protect it from the cosmic radiation, producing fewer clouds and a hot Earth. Now that can have a big effect, as much as a 10% change in the temperature of the Earth. If you have to worry about the sun being the direct radiation, infrared radiation coming from the sun, it changes very little. God designed our sun to be very stable and not have much fluctuation to it. But apparently, because of the activity of the sun, you can get more fluctuation in the cloud cover on the Earth, and that can change more of the temperature. There's a fellow by the name of Jasper Kirkby, he's inside a cloud chamber he designed and built at this laboratory in France. It's a gigantic chamber in which he can build pristine clouds in the laboratory and inject radiation, like cosmic radiation coming from space, to see whether it would produce cloud droplets and increase the likelihood of more clouds. He's been working on this for about 10 years now, has made some progress, shows that the radiation coming from the laboratory into the chamber full of vapor, water vapor, simulated clouds, produces small cloud droplets and increases the likelihood of clouds. But that's not the complete answer yet, so he's still working on it. Let's see here. Okay, then recently there was some reports that came out independent of all this information in a report which I'm going to show you how to get a copy of for yourself on the internet here shortly. It's called The Climate Surprise. And it starts off with the fact that we need to recognize that carbon dioxide is not a pollutant. If you remember, about 4 years ago or 5 years ago, the Obama administration forced the Environmental Protective Agency, the Environmental Protection Agency, to control carbon dioxide in the atmosphere because it was declared a pollutant. The Supreme Court determined that carbon dioxide is a pollutant. It's not a pollutant. In fact, when you breathe out, you're breathing out carbon dioxide. The plants are taking it in and growing. When you breathe in, you take the oxygen that the plants are producing. It's a natural process that God created. How can it be a pollutant? In fact, carbon dioxide is a great way to grow plants more quickly. Did you know that many of the producers of plants and vegetables and so on in greenhouses actually release carbon dioxide into their greenhouses, increase it by a factor of 3 or 4 more than what's in the atmosphere today, and plants will grow 2 to 3 times faster and use less water. So carbon dioxide is a nutrient for plants. So it can't be a pollutant. It's actually a benefit. Plants grow faster, use less water. Even in the oceans, one of the criticisms today is that carbon dioxide absorbing into the ocean is acidifying the ocean. Now that's actually a phony statement. It does make the ocean slightly more acid, but it's still not acidic. In other words, the pH, as you go toward an acid pH, is acidification. But the ocean is not acid, it's more alkaline. But it turns out that carbon dioxide in the ocean, which is a little bit more acidic than today, actually the phytoplankton grows better, very much like plants on the continent. So carbon dioxide makes the plants in the ocean grow as well as trees and grasses on the continents. Okay, now assuming that carbon dioxide is the cause of global warming, you know how expensive it would be to try to reverse global warming by cutting back on carbon dioxide. We basically have to get rid of all coal production, natural gas production. We can't have oil burnt. We got to get rid of cars. We have to shut down electrical generation. All of these things that is the goal of the current administration, it would require that and much, much more. It would destroy our economy. And the worst thing that would happen is the poorer nations are going to be hurt even worse. they would not be able to allow for any kind of electrical development or other things that would help get them out of poverty and out of the situation in which they live. So that's going to be an extremely expensive process and damaging to our whole economy. It would actually be cheaper to try to accommodate to a slight increase in temperature and actually take advantage of some of the benefits it would have. For example, if there is global warming, that means that we can plant crops and do agricultural processes further north on our globe. And it's actually easier to live when the temperature is warmer than it would be if you had an ice age. Can you imagine cooling it down, trying to live under an ice age like we had in the past? So warming is actually beneficial to some degree. I have a good friend who basically says, you know, based on what we know, we should be actually trying to put carbon dioxide into the atmosphere. We're actually living in a situation where the atmosphere is lower in carbon dioxide than would be beneficial. You think, didn't the dinosaurs live in that kind of environment? Where'd all the coal came from that got buried by the Genesis flood? It was buried plant material which grew in a high carbon dioxide environment. So it kind of changes the whole concept. And that's how somewhat it relates back to a biblical issue. Finally, well, I already said that. So that comes out in a report called The Climate Surprise. Finally, here's the conclusions of my talk, and then we're going to stop and have a few questions and answers. Global warming has been occurring for over 150 years, even before industrialization. It's only been in the last 40, 50 years that carbon dioxide has been an issue from industrialization. So it couldn't have happened before that. In fact, there's even evidence that on some of the other planets, temperatures have been increasing. We didn't do that. The global warming is probably due to natural causes. We probably have had some effect and will have in the future, but it's not the main cause of global warming. In fact, carbon dioxide is much, much less of an effect than if you put more water vapor in the atmosphere. Water vapor is a much greater greenhouse gas than carbon dioxide is. Okay, the one theory that shows great promise that I like is the solar activity and its connection to that. We've already talked about that a lot. And finally, global warming actually may be beneficial. So now, here I'm going to give you the two reports here, and really, you don't need to try to copy well, I didn't give it to you here anyway. One of these is, I was giving you the computer link for it. I had it on one of my earlier drafts, but I figured it was so long you couldn't write it down anyway. One of the reports on the left there is by Roy Spencer in just this last summer, 2016. It's entitled, A Guide to Understanding Global Temperature Data. And he goes through a lot of the things I talked about tonight, reiterating. That's why I say the two of us really think alike in terms of how to understand what the data is telling us. The other one is The Climate Surprise, and the authors on that are quite interesting. Craig Idso is the one that really stressed the idea that increasing carbon dioxide actually helps plants grow better. Roy Spencer, you already heard about him, he wrote this one. Richard Linson is a renowned leading atmospheric dynamicist at MIT. And he and I have kind of bumped into each other from time to time on similar topics. Here's the most interesting one. Anybody know who Patrick Moore is? He was one of the founders of the Greenpeace movement. You remember the guys that went out with their boats and were trying to protect the whales? Well, that's one of Patrick Moore. He is now a major skeptic of global warming. And he is the one that is a specialist in ocean information about the value of carbon dioxide in the ocean helping phytoplankton go. But I didn't talk much about phytoplankton. It's actually the bottom of the food chain for the small microorganisms in the ocean, which larger organisms eat, and then small fish eat, and they get eaten all the way up through the chain. So the phytoplankton is the basis of the whole food chain in the ocean. And he shows a good case for the fact that carbon dioxide actually helps that grow more. Okay, I'm going to stop at this point. You got a lot of information. You're probably on overload. I'm going to have Heinz come up, and he and I are going to after a few things, we're going to have a little bit of a discussion, I believe.
Let's give Larry a hand for that. Yeah, that was a lot of information to take in, but very interesting. Some of you may know myself, I did a study of this as well. I'm not a climate scientist, but I am a scientist and a physicist, so I did an analysis of what they were reporting, and this started about 2009. And so I asked the question, why is there so much controversy about this? I mean, the science should just tell us the answer, right? So I did a pretty detailed investigation and wrote a number of reports on that. In fact, I published that on my internet website under global warming. You can find it on my website. I give about 120 different technical references to back up my opinion, and I ended up where Larry is, and Roy Spencer and Christie, Michael Ord, who has spoken here before, he's a meteorologist, and so we all agree pretty well on the physics and the results of this. So how did we get into this situation? And Larry, I'm going to make a few statements, maybe ask you a few questions, and you can do likewise. And how we got here.
You might, in that process, you might refer to a few of the institutes that have been involved in this that provide information like this.
Well, you're probably more familiar with those, but they're like the
like Cornwall and
yeah,
Heartland.
Cornwall Alliance. There's a group on the net, Cornwall Alliance, and they look at our responsibility as caretakers of the creation that God gave us. And yes, clearly we need to take care of what we're given. But also they've come to the same conclusion, and they agree with what Larry has to say here too. But something that some of you may not realize is, how did we start this whole effort, an investigation? Back in the 1990s, when the UN set up the IPCC to look at the climate change issues, they asked the question of the scientists, look for human-caused causes of global warming. They didn't say look for a natural cause. They said look for human causes, and I think that's what started us down this path.
Yeah, Heinz and I were talking about this a little bit this afternoon. It kind of reminds me of our space program with NASA. NASA, the thing that drives NASA is looking for extraterrestrial life, and that drives their whole thinking. Now, I'm a supporter of NASA. I love what they've found and so on, but I have a major disagreement with them looking for intelligent life. Carl Sagan once said, "I'd be happy if I could find dumb life," and they haven't been able to find it.
Yeah, that's very true. And what Larry also said was the looking for, like science supporting evolution. I see it the same kind of issue with global warming, looking for science to support my conclusions, if you will. We know what we're looking for, and as Larry says, you can't get a grant from the government unless you agree with what you're going to find. And that's a real problem for a scientist.
One of the criticisms that we researchers at the Institute for Creation Research have always had was from the conventional scientific community was, you guys are begging the question. You already know what the answer is, and you're doing your science trying to prove what you find. And yet that's exactly what they're doing. They're going out and saying global warming occurs. Now we need to go out and prove it. It's exactly the same approach.
And look for one cause.
Right.
Right. And that determines what kind of a grant you can get as a scientist. And that's, unfortunately, it's true in science in general. They've redefined science. They've hijacked the definition of science to limit the answers to what they think is acceptable.
Well, even more than that, they've also outlawed the concept of anything supernatural. By definition, God doesn't exist, and every explanation that you have to come up with has to be completely natural.
Yeah, In fact, some of you may have seen my lectures where I asked the question of Dawkins, for example, how do you explain this? How do you explain something that seems to be designed? And they keep on saying, well, we don't know the cause of the information that's part of that design, but, you know, it may look designed, but it really evolved.
Oh, I can't pass this one up. I've had conversations and correspondence with Carl Sagan, and one of the last letters I got from him before he died was, he says, I think I can explain everything we observe in nature except for one thing. I can't figure out where the laws came from.
Yeah.
Isn't that an interesting admission?
And Stephen Hawking says, because the law of gravity exists, therefore, the universe could have started from nothing. But who created that law of gravity?
Exactly.
Well, anyway, we could go on this kind of a topic, but I'd like to open up the question and answers to the audience. If you have a question, raise your hand and I'll bring the mic around. And in the meantime, how's this ministry supported? Well, we look for free will offerings to help us to support the ministry. We are now a 501c3 organization, so if you're concerned about tax write-offs, and we can take care of that too. So if you feel led to help us on that, you're welcome to do that. And at the end, of course, the book table and DVDs are available too. So while the men come forward, let me just take the mic around and take your questions.
Well, first, thank you for your presentation. You mentioned the situation about the CO2 growth down in Hawaii, up to 400 parts per million.
Right.
And my question is associated with, I didn't hear you talk about that it had an influence on the temperature as a relationship to that growth. And when you talk about the overall total atmosphere, when you look at the temperature outside, I would imagine that there is a constant equilibrium between all the gases. So how can you claim that the CO2 has an influence above any of the other gases, including nitrogen and oxygen, that is in majority in the atmosphere? Could you elaborate on that?
Yes, be glad to. Carbon dioxide is called a greenhouse gas because it's similar, or there's an attempt to describe it in lay terms like a hothouse or a greenhouse. When the sun comes in through the glass and it strikes the plants or the soil inside of a greenhouse, the short wave solar radiation is converted to longer wavelength infrared radiation. It's what you feel like when you open the oven and you feel the heat in the oven, or you go by your wife's or whoever does the ironing in your house. You go by a heated iron, you feel heat coming from the iron. That's infrared radiation. And so the solar radiation is turned to infrared radiation in the hothouse or the greenhouse, and it can't get back through the glass out to space as easily as the shortwave radiation came in. So therefore the hothouse warms up to the point where there's then an equilibrium of the rate coming in and the rate going out. So you have to have a warmer temperature. In a sense, carbon dioxide is that way. It's like, it's called a greenhouse gas because it allows the atmosphere to be warmer. And that's true for all the gases, but more importantly for carbon dioxide and particularly water vapor. They function more effectively that way than all. If we didn't have any atmosphere on the Earth, it'd be like the moon. When the sun comes in, it gets extremely hot when the sun is shining on that spot, but at night it gets extremely cold. The same thing would be true here on the Earth, except we have an atmosphere which modulates it and it keeps it warmer, and it stays warm uniformly from day to night. So the CO2 is a greenhouse gas in that it amplifies that effect, and it's because of the way the molecule is formed. It's made up of 3 atoms, a carbon and 2 oxygens, and because of the way they vibrate, it functions as a greenhouse gas. I don't know if that's what you were looking for or not. And it affects all the other gases too. When the carbon dioxide gets warmer, it causes the oxygen and the nitrogen to be warmer too. So the whole atmosphere is affected by it. Yes, ma'am. Oh, I'm sorry.
So what I was wondering about was impact of refrigerants against climate change. I know that there's been a big deal in Kyoto Protocol and Montreal Protocol, and I've not seen that as part of the discussion. And just as a side comment before we get too much further into that answer, I know that water is 500 times more potent in being able to provide heat transfer than air. So just as a comment.
Okay. Yes, the freon, or the refrigerant in air conditioners and refrigerators and so on, it was discovered back in the late 90s that the freon we'd been using, when it escaped in the atmosphere, would get up into the upper atmosphere and toward the polar regions, and would be affecting the conversion of ozone. It would actually eat up the ozone on the surface of ice crystals in the cold regions of the upper atmosphere near the poles. It was actually theoretically suggested initially. It was then confirmed by direct measurements in the laboratory that it worked that way, and it was also confirmed by direct measurements by high-flying aircraft in the polar regions, observing the freon on an annual basis eating its way and forming a hole over the poles. So when that was first suggested, we've got to change stop using freon. I was at first skeptical, but when I did the study in the literature, I was supportive of that because it was a legitimate concern. And so we changed the type of freon that we started using, which was much less, had much less of an impact, and it actually started closing the hole in the upper atmosphere in the polar regions. Now, what was surprising was that the people who were involved in this had suggested that they claimed success within a matter of a year or two. And it took, there's a cycle to that. It was like the 11-year cycle with the sun, where the hole would open up and then close back in. Well, that so happened that we reduced the use of that particular freon at a time when the hole was starting to close in. So when we observed the hole was closing in, everybody said, hey, we did it. Well, 10 years later, it started opening back up again, but it didn't open as much. It's going to take about 50 years for the change that we made 10 years ago to really have its full effect. Now, there has been discussion recently that we need to get rid of freon completely and use some other type of gas, because even with the improved freon, it still has an effect. So I'm a little less supportive of that idea. For one reason, when we changed from the original freon to the secondary one, our refrigerators and freezers were only half as effective. So it took more energy to cool things than it did before. And I don't know if we get another gas that would be effective enough to avoid that problem. So I'm not sure what to think about that yet. But it is in the discussion. I haven't heard a lot about it, but it's secondary to the other issues right now.
I had a question about that chart from Hawaii showing the breathing effect.
Yeah.
Why wouldn't that be canceled out, since you've got winter in the southern atmosphere when you've got summer in the northern, and vice versa?
Yeah, that's a good question. The reason is that it's affected mostly by the plants on the continents in the northern hemisphere. The way in which our globe is situated is most of the land mass is in the northern hemisphere. So the plants on the continents in the northern hemisphere drive that effect. You're right that the southern hemisphere would counterbalance that, but not enough to do away with it. See, I got an answer for everything. No, I don't really. Yes, sir.
On your chart, you had the going from 300 of a millionth to 400 of a millionth. I think most people can't grasp that in their mind. And
Yeah.
I hope you can get an illustration to show that. I mean, it's actually 4/100ths of 1%.
Yes.
And it went from 3/100ths of 1% to 4/100ths of 1%. Most people can't even imagine what that is. It's so infinitesimally small that to build this whole thing around that if you just take what the atmosphere is made up, nitrogen, oxygen, and all the rest of the gases, and it's only 4/100ths of 1%. It's such a stretch
Yeah.
to have to go out there and try and find that this is what's making the change. It is in the myth category for sure.
The argument against that, which I am not fully supportive of, is the idea that the carbon dioxide and water vapor have an effect all out of proportion to what the other gases do. So they basically say it amplifies that effect dramatically. I don't believe it. I agree with your concern as well.
Do you happen to know if any data came out of the carbon dioxide research area near Temecula, California? Is that where some of this climate surprise came?
I'm not. I know where Temecula is. I've been there several times, but no, I don't know. Why do you, Heinz? Could you go back and ask, why do you mention Temecula? You know something that I don't?
I doubt it. I happen to drive past it on a regular basis. I know it burned about 10 years ago,
Yeah.
and I don't know how long it was in existence. But they were doing research on plant growth with carbon dioxide. And they were shooting carbon dioxide at certain areas, and I think I saw a couple that were actually covered, but most of them were pylons with holes in them that evidently produced carbon dioxide, and were checking on the plant growth.
You're talking about in greenhouses?
I don't think, no, not all of them were in greenhouses. They were just circles of
They were putting
gases.
in the irrigation system or what?
No, it looked like big open areas, and there was white pylons around it with holes on the sides aimed at certain areas of
Oh,
plants.
you're not talking about the solar, it's out near Temecula. There's a solar generating plant with mirrors that point up toward a big tower.
No,
That's
no,
not
this
it?
was called carbon dioxide research.
No, most of the carbon dioxide research I'm referring to occurred down in the southeast, in Alabama and Florida and down in that area. I'm not familiar at all with Temecula. Sorry. Yeah.
I'm from public school, and so I had to go through biology and everything, and I actually got a good grade. The teacher was really surprised. So like this issue is brought up before, you haven't addressed it yet. Coral bleaching. What are your thoughts? What do you know about it?
That was one of the concerns that I have. That's the general explanation, in that the carbon dioxide may be killing the corals and causing them to be bleached. That was one of the reasons I was pleased to see this evidence for carbon dioxide having a beneficial effect for phytoplankton. But I don't know what the explanation for that is, other than the fact it seems to be occurring around places that are heavily used by people. If that was the case, you'd think it would be global and almost completely uniform. There are places where it's not affecting it at all. The places where the corals are being bleached, like for example Hawaii, I've done a little bit of scuba diving, not scuba, snorkeling, but people who do scuba diving say that you don't want to go to Hawaii to go scuba diving because all the corals are just almost dead. But you go out in places where there's not much activity yet, and you find the corals are still alive and beautiful. So I'm not sure, but what it may have something more to do with nearby activity rather than the CO2 in general. I just don't know. Yeah, we have all kinds of effects. Yeah.
So as I was looking at your graph, several of them, I noticed that the temperature fluctuations for global warming and cooling were just a few degrees.
Yes.
Is that true?
It's about 1 degree Fahrenheit at this point the overall change. If you averaged it all out over the last 100 years, they estimate about 1 degree increase in 1 degree Fahrenheit increase over the last 100 years.
Well, it doesn't seem like that much.
Doesn't
Does
seem
it
like,
have that profound
you
of
wouldn't
an
notice
effect?
that at all. In fact, the thermometers that we measure, you can't measure it that closely. All you do is pool it all together, and it's a statistical variation.
Okay.
So it's very difficult.
So I'm not going to be able to grow watermelons next summer?
No.
Because it's not going to be that much warmer?
No.
Okay.
The natural variation in the atmosphere is absolutely incredible. It swamps that small change. On a daily basis, or even a yearly, or even a millennial, or not a millennial, but a 100-year basis, you wouldn't notice the effect on your climate at all.
Okay, all the years I've been coming to these creation science things, they've told us that the Ice Age was caused by Noah's flood. And then you had this mini Ice Age caused by lack of solar activity. Is there some connection here I should put together?
Well, okay, I didn't say that. I intended to. Actually, the concern, as I mentioned earlier, by the conventional community is that the atmosphere is very unstable. It doesn't take much to kick it off and cause a major climate change like an ice age. That's one of the bases why they're so concerned about this. You never hear that expressed, but the scientists that are in the know, that's what drives them. Yet, if you stop to think about it, if in fact the climate was affected by a gigantic, catastrophic global flood, you can imagine what that would do. And my mind, and I've given this talk, I don't think I've given it here. Have I given the Ice Age talk here? I don't believe so. The basic idea, Mike Ord and I agree on this. In fact, Mike was the first one to suggest the basis of this, that the Genesis flood was so catastrophic, both geologically and atmospheric-wise, that it released a tremendous amount of heat during the year of the flood, including the basalt that came up on the bottom of the ocean. Let me just give one example there. The Earth has a 40,000-mile long mountain chain on the bottom of the ocean. It's called the Mid-Ocean Ridge. It runs right down through the Atlantic from Iceland all the way down to into South America, goes around the globe near Australia and up through the Pacific Ocean, goes even into the Arabian Sea and up into the Persian Gulf. That mountain chain is in places 6,000 feet high off the ocean floor and hundreds of miles wide, 40,000 miles long. It's like a baseball seam on a baseball, made out of basalt, which was originally molten hot magma. All that heat was released into the oceans during the time of the flood and caused the ocean's temperatures to be as much as 100, 120 degrees Fahrenheit globally. It's like a hot bathtub or a warm bathtub. It would have produced a gigantic El Nino effect. That would be what caused the Genesis, the Ice Age, in my opinion, because the oceans were warm, the continents were still cold because of effluent from the volcanoes keeping the sun from coming in. You had warm ocean heating the atmosphere, flowing over the continents, and dumping the precipitation on the continents as snow. That would have produced the Ice Age. The Little Ice Age was a minor thing. It would not have produced all the glaciers that we have on the Earth. The Genesis flood and the Ice Age that caused that, that's all, we're all recovering from that, and the glaciers have been melting ever since that Ice Age produced by the Genesis flood, and the oceans have been rising. People are concerned about, well, the oceans are rising. They've been rising since the Ice Age. So that's basically the alternate explanation. Yeah, right. And they've risen hundreds of feet in the past.
Two questions. Number one, you mentioned back at the time of the flood there was 25% more carbon dioxide.
25 times as
25
much.
times.
25 times as much.
The question would be why? And the second question is just like the chart they showed, when they talk about temperatures at 1000 AD and all that, how do they know what the temperatures were back then?
as I say, those were measured by proxies. You have to have some other physical feature that changes as a function of temperature, typically geologic change. So when it changed, if you got the temperature calibrated with those geological changes, you can then say the temperature changed that much back then. You don't measure it directly, you infer it. Okay, what was the first question? I forgot. Okay, what caused that? Basically, as I understand it, and this is based on the fact that if in fact the Genesis flood occurred, it buried the vegetation that was on the earth at that time, forming the coal and oil that we find today. If that vegetation was on the surface of the earth, it would be consistent with a tremendous amount of carbon dioxide in the atmosphere, because there's a balance between the carbon dioxide going in and out of the atmosphere. And if you had that much vegetation, you infer that there was that much carbon dioxide. There are also some independent measures of the carbon dioxide in what are called vesicles. These are like small glass beads that were released in volcanoes, and it's like a small whiff of air from in the past, and they measure that and find that there was much more carbon dioxide. Even there's also, well, I won't get into that. There's other evidence as well.
Okay, the last question from the back here.
Oh, we got a good questioner here. Yes, ma'am.
What is carbon dioxide exactly?
Carbon dioxide is one carbon atom with two oxygen atoms attached to it, kind of in the shape of a Mickey Mouse head. You know, it's kind of like the carbon is the big atom and the oxygen are two little ones like ears. That's a carbon dioxide molecule. And when we, in the life processes, as our body converts food into energy, it produces carbon dioxide. And when we breathe out, the carbon dioxide in our lungs goes out in the atmosphere. We then breathe in the oxygen, which allows us to metabolize the food. That's chewing up the food and chemically doing chemical processes. So we have this conversion between oxygen and carbon dioxide back and forth.
Well, thank you for that good question. Remember, it's not a pollutant. Larry, thank you very much for doing that presentation. Very informative and useful. For those of you that follow what's happening in Washington, that's the Washington on the other side of the continent, Trump just appointed a new EPA director who is a global warming skeptic. But we won't discuss politics here. So anyway, I want to remind you, Jonathan Parks, he produced Jonathan Parks. Pat Roy will be here December the 9th to speak at the forum, and he will speak on another topic that is very near and dear to my heart too, and that is debunking evolution, looking at the 11 common pillars of evolution that evolutionists use to defend their position. And he takes input from a lot of scientists. All of those scientists have degrees, doctorate degrees in areas of science of their expertise, their discipline of expertise, and he will show that the science does not support evolution. So if you're concerned about that, as you saw by the short DVD trailer that we showed, that is the issue that trips up a lot of young people. They think evolution is true because they hear it repeated at school all the time. So if you have an interest in that, come there on December the 9th. He's also going to be available for about 4 or 5 days that weekend, and we already have 2 homeschool groups lined up that he's going to speak to, one here in this church and one in Snohomish. The contact names and phone numbers and emails are on the website, so if you have an interest in that, or just contact me and I'll get you in touch with them. So be aware of that. The second one I want to make you aware of, the next slide again. This is his schedule, okay? We do not have him signed up yet for Saturday, the December the 10th, but I'm leaving that open, so possibly there's some other homeschoolers that would want to have a workshop on a Saturday morning and have him present there as well, or a high school group, what have you. And then he will also be available during the weekend for a church service and or Sunday school if you know of somebody that might want that as well. Okay, and then the next slide here. Remember that Jason Carlson, who is president of Christian Ministries International, that organization has actually been around for 40 years. It was founded by his father, Dr. Ron Carlson, in the 1970s, and he passed on in 2011. Jason and his brother Gerard are both pastors, and they speak on the topics of interest to help the church contend for the faith that we have. And Jude 3 is their verse, and their website is called jude3.com. So if you want to get some background on him, you can look there. And of course, all the information is on the website. So I just want to summarize that. Remember that the DVD I said that was going to be available. You know, the one that the trailer, which showed that the topic of evolution is a real challenge to our high school and college students. There's a copy of that available if you want to listen to it and pass it on to other members of your church and let them become familiar with the issue as well. There's a trifold on who we are, the Apologetics Forum on the back. All the flyers on the back table there are available if you want to get more information on what we do. And remember, the talk that Larry gave here and all the other talks, they are recorded, video recorded and audio recorded, and in most cases we will also make the PowerPoint slides available of these presentations. So if you want to go back over some of this material, it'll all be on the web within the next week. And for those of you, and probably there's a few people on live streaming as well. We do live streaming, so for people that can't be here, that are out of town or for whatever, they can listen on live streaming. Just go to the website, click on live streaming, and you'll have it. So with that, that's what's happening. I want to thank you for your attendance and for your support of this ministry. We think it's a very important message that we're trying to get out to our youth and young people, parents, grandparents, what have you. You know, we all need to know this, and we will continue to make an effort to bring some good speakers in like we have here. And again, thank you for your support. Let me just close up in a word of prayer, and then in the back there are refreshments and, of course, the resource tables that you can avail yourself of as well. Father, we just come to you just again to thank you for your blessings upon us. Thank you for the folks that could come up and learn what this global warming issue is all about, and just help us to share what we've learned. And we thank you, Larry, for his ministry. Even in his retirement, he's sharing his knowledge, and we appreciate that, and we thank you for that as well. And we just thank you that you have left evidence in your creation of the truth of your word. And we pray these things in Jesus' name. Amen.